So we're going to get started with the next section. So we're going to be starting to talk about the LED calculator design. You guys just learned a little bit about binary and logic gates, so now we're going to apply that to our calculators. So we're just going to do a little bit of review. So I didn't fill out the first two, but so these are the main gates that we're going to be using. So the NOT gate, which basically just inverts what it's given, and where both inputs need to be 1 in order for the output to be a 1. Or where at least one input needs to be a 1, and XOR, which only one input can be a 1 for the output to be a 1. So those are the main gates we're going to be using for this project. So Boolean algebra is the way we use to describe these. So instead of writing the words and or not, and keep on having to write those, we use symbols to represent these. So for not, we'll either use like a tilde or we'll put a line on top of the variable that we want to not. For and, we'll use multiplication, so either a dot or an X, whatever you like to use for that. For or, we will usually use addition, so the sum symbol. And then for exclusive or, we'll be using a circled plus sign, so direct sum. So yeah, and those are the symbols we use. And so if you guys follow, it's going to be on chapter 15. It's one of the first tables in that chapter. There's going to be this chart, approximately. 14. 14, yes.
Is that it?
Yes, yes.
Page 139.
So it's going to be on page 139. So have you guys filled out these charts already? Yeah, so yeah, if you guys could start filling these out. So fill this one out.
Yeah.
So get used to the terminology. So yeah, zeros and ones. Right, so the first two columns are going to be the nots of the, so A and B are basically your inputs, and these are the values we're going to be giving you for those rows. First two columns are the nots. Second two columns are ands. Next two are ors, and the last two are exclusive ors. So that helps. We're gonna go row by row and go through the answers. So for the first row, what's not A?
1.
1. Not B?
1.
1. A and B?
0.
0. B and A? Does anyone have that?
I have it, but I'm just giving
Yeah,
you
so B and A is also 0. A or B? It's gonna be 0.
all of those are zeros.
Yeah. B or A is 0. And then A XOR B is 0. And B XOR A is also 0. So then let's go. So for A 0, B 1, not A, 1, not B, 0. A and B, 0. B and A,
0.
A or B,
All
1.
of them are ones across after that.
B or A, 1. A XOR B, 1. B XOR A, 1. Okay. The next one, not A is 0. Not B is 1.
1.
AB,
0.
0. B and A,
0.
0. A or B, 1.
All the rest are ones.
Yeah. Then B or A, 1. A XOR B, 1. B XOR A, 1. So, and then last one. So not A, 0. Not B, 0. A and B, 1. B and A, 1. A or B, 1. B or A, 1. And then last two XOR A XOR B, 0. B XOR A, 0. Yeah, so.
I'm sorry, what were the last two?
Oh.
Oh, the algebra.
0 and 0.
All right.
Yeah. So did anyone notice like any patterns with these that we gave you? So did it make like a difference if we had A, like if we switch A as the first variable we listed versus b. No. Yeah. So the reason we call it Boolean algebra is because it has many of the same properties as arithmetic algebra. So this is our commutative law. So basically it's just stating that the order that we state things doesn't matter. It's more about the actual action. So a and b is going to always be the same as b and 1, b and a or b is going to be b or a, and then vice versa, so on for all the other functions. Yep. And so then we have another table. It's going to be the next one. We have another table. So I'll give you guys like a few minutes to fill this one out as well. And if you're done with that one, there's more if you want to fill those out as well. So we had 2 of you come up and do them, and yes, they're all right. So yeah. Yeah.
Sometimes he said I have to accept
Yeah. So for
behaviors as that they are.
So for A or B and B or C, that's just like an intermediate row. So as long as one of these 2 variables was 1, then the result was 1. And then we use those to compare the next 2 rows to either. So for this case, this result compared to C. And then in the other row, we're comparing B, the result of B or C to A in OR functions. And then with the last 4 rows, instead of doing ORs, we're doing ANDs. So as long as both inputs were 1s, then that function was also a 1. Okay. And then we ANDed that. The output of that, we ANDed with either C or A and the other one. So I'm going to put the answers on the board and then erase these. So if you guys want to just check over that you guys got these. So did anyone notice like any patterns with these, like with any of these? So the associative probably so, right? So so our 5th column and our 7th column have the same answers as well as our last column and our 3rd to last column. So this is our associative property. Oh yeah, this was the associative property. Sorry, it's kind of hard to see. So basically saying that for when we're comparing 3 of these things, it doesn't matter which 2 we compare first, what order we put these in. If they're all going through the same kind of function, the result will always be the same, right? So if we're doing AND, it's a little hard to see. As long all 3 of them need to be 1 in order for the result to be 1. It doesn't matter which order we analyze, like looking BC first and then looking at that compared to A or vice versa, whatever. As long they all need to be 1. For OR, right, it doesn't matter which order we compare them. As long as one of them is 1, then the answer will always be 1, right? Because the condition for OR is that at least one has a 1. And then for XOR, the same property kind of applies. Only one of the variables can be a 1 in order for the total answer to be a 1. So last table. So it's going to be the next one. So I'll give you guys a few more minutes to fill this one out if you haven't already. So those are all the correct answers. So does anyone know what the law that was used here is called, or property, whatever you like to call? Yeah, so this is our distributive property. So when we combine our AND statements and our OR statements and our XOR statements, it behaves kind of like how we do math when we're doing multiplication and stuff in parentheses. So it's basically saying how if we have something in parentheses and we are trying to AND that, we can kind of multiply that thing out into 2 parts. So for one of them, it's for the A parentheses B plus sign C, so would also be equal to A and B or A and C. You guys kind of saw those in the tables you filled out, and then same thing for XOR. And so the reason why we call this Boolean algebra, even though we're not really adding anything, it's just more of a comparison, we just do this because we find that we can use a lot of the same properties in algebra to do some of our equations to compare a lot of these variables.